Spacecraft avoidance and elimination of space junk, a growing concern. As humanity continues to explore and utilize space, the issue of space junk has become increasingly pressing. Space debris, which includes everything from discarded rocket stages to lost tools and debris from collisions, poses a significant threat to operational spacecraft. In order to protect these valuable assets, spacecraft operators must employ a variety of techniques to avoid and eliminate space junk. One of the most straightforward methods of avoiding space junk is to simply maneuver the spacecraft out of the way. This can be done using thrusters or other propulsion systems to change the spacecraft's trajectory and avoid a potential collision. However, this method is not always possible or practical, as it can consume a significant amount of fuel and may not always provide enough time to react. Another technique that spacecraft operators use to avoid space junk is to use radar or other sensors to detect and track debris. This allows the spacecraft to see potential hazards and take evasive action, such as changing its trajectory or deploying shields to protect itself. Additionally, ground-based radar and other tracking systems can be used to monitor the location of space debris and provide warnings to spacecraft operators of potential collisions. In addition to these active methods, spacecraft can also employ passive measures to protect against space junk. For example, they may be equipped with shields or other protective measures to withstand impacts. These shields can be made of materials such as Kevlar or other high-strength composites that can absorb the kinetic energy of impact and prevent damage to the spacecraft. Eliminating space junk is a more complex task, and several methods have been proposed to achieve this. One method is active debris removal, ADR, which involves using a spacecraft to physically capture or move debris out of the way. Methods include using a robotic arm, a net, or a harpoon to capture debris and then deorbiting it. However, this method is currently not yet operational and still in the research and development stage. Another method is deorbiting, which involves using a spacecraft to apply a small amount of thrust to debris, changing its orbit so that it will re-enter the Earth's atmosphere and burn up. However, this method is only effective for debris that is in low Earth orbit and also require a lot of energy and cost. Laser ablation is another method that uses a ground-based or space-based laser to vaporize a small amount of material on the surface of debris. This creates a small amount of thrust that can change the debris orbit, causing it to re-enter the Earth's atmosphere and burn up. However, this method is still in the research and development stage and it's not yet clear if it will be practical for large debris. Net capture is a method where debris is captured using a net or other trapping device and then deorbited. This method is still being tested and developed. It's worth noting that some of these methods are still in the research and development stage, and many face technical and financial challenges. Moreover, the most effective way to eliminate space debris is to prevent it from being created in the first place. This can be done by implementing better debris mitigation guidelines for space launches, designing spacecraft and satellites that can withstand collisions, and by creating regulations for the end-of-life disposal of spacecraft and satellites. In conclusion, avoiding and eliminating space junk is a critical concern for spacecraft operators. By employing a combination of active and passive methods, such as maneuvering, radar and sensors, shields, and other protective measures, spacecraft can protect themselves and continue their important missions. Additionally, it requires international cooperation and regulations to prevent the creation of new debris and the implementation of effective methods for removing the existing.